We are going to look at some more exponents, and we're going to do some division properties today. So we have the quotient of powers, and again, similar to before, the name is not so important, but you have to know how to use the property. So what we have is a to the fifth over a to the third. So if we would write that out kind of longhand, it would be 5 a's on top and then 3 on the bottom. So how do we simplify that? Well, we can cancel out. Cancel out a factor of a, cancel out another factor of a, 1 on top, 1 on the bottom. So I'm left with 2 on the top. So that's equal to a squared. So how we can get that then, how do we get 2 from 5 and 3? Well, we subtract. 8s of 5 minus 3. So when we have a quotient, we are going to subtract the exponents. So if you divide, again, it's the same base, it's a, we're going to subtract them. So let's look at some examples. Here we have the base of 4s, so we're going to write our base of 4, and then we have a 6 up top, 4 on the bottom. 6 minus 4, which is 4 squared, and if we need to calculate it, it's 16. If a question would ask for write it as a single power, that's when you would write 4 squared. So here we have x as the base, and then 4 minus 7. That's equal to x to the negative third. Now we don't like negative exponents, so we're going to make that 1 over x to the third. Remember, anytime a exponent is negative, if you would like to make it positive, you switch it between numerator and denominator. So here is in the numerator, because we could put x to the negative third over 1. So we bring it to the denominator, it becomes a positive 3. We got to do two things here. Let's combine the top first. So x to the fourth times x to the third, we learned in the multiplication properties of exponents that we needed to add these numbers because they each have their own base. So it's going to be x to the 7th over x to the 5th. Now we subtract them, so x to the 7 minus 5, which is x squared. If you think of doing this longhand, writing it out like we did over here, up top here, there'd be 7 on top, 5 on the bottom, so you keep canceling out until you can't, and then we're going to run out on the bottom, and there's going to be 2 x's left on the top. The next is the power of a quotient, and this is similar to the multiplication. We have to give the 5 to the a and the b. So the 5 gets given to the numerator and the denominator. So we're going to give the 3 to the 1 and the 4. So it'd be 1. 1 to the third is 1. And then 4 to the third is 64. So 1 over 64. Now here we got to give the 2 to the 4 and the x, but we're going to make sure we don't forget the negative. 4 squared over x squared. 4 squared is 16, so negative 16 over x squared. Now here we got to give the negative 4 to everything, so 3 to the negative 4th over 2 to the negative 4th. Again, I don't like negative exponents, so this 3 to the negative 4th, I'm going to put in the bottom, because then it becomes 3 to the 4th. And 2 to the negative 4th, I don't like the negative 4, so I have to move that to the top to make it positive. So I'm going to make both my exponents positive. 2 to the 4th is 16, and 3 to the 4th is 81, so it becomes 16 over 81. And that is in lowest terms, so we're going to leave it just like that. So that concludes our properties today. Let's put them all together based on what we've learned previously and today. So some big complicated problems. So these are two fractions, and let's go through and multiply across the top and multiply across the bottom. So I have 3 times 12. So I'm going to rewrite everything, and I'm going to rewrite it as the numbers first, and then the x's. So I have an x to the third, and an x squared, and then the y's. I got a y, and then a y squared. And then on the bottom I have 4x y to the third. Now if I combine it, 3 times 12 is 36. And then I have x to the third times x squared. So they each have the same base, so I'm going to add my exponents. X to the fifth. Same thing here with y's. Y to the first. So 1 plus 2 is y to the third. Now this is a little different. What we have here is really, we're going to treat this as 3 separate problems. Right? We're going to do 36 divided by 4, which is 9. We're going to do x to the fifth over x, so they have the same base. We're going to subtract 5 minus 1, x to the fourth. And here, x to the third over x to the third, so 3 minus 3 is 0, y to the 0 is just 1. So my final answer is 9x to the fourth. So when we rearranged them here, here's why. Because now we can line them up real nice. Reduce the numbers, reduce here, simplify the x's and the y's. With number 8 here, we're going to give the 3 to the top and the bottom. But on the top, we have to give it to multiple things on the top. So we have to give it to the 3 and the x squared. So 3 to the third is 27. Now it's x to the 2 times 3. It's a power to a power, so 2 times 3, which is 6, over y to the third. And that's a simplified. The numbers are simplified. The x's, there's none to reduce, and the y's, there is none to reduce. Finally, number 9. Let's give the 3 in this one. So I'll rewrite the first one. Give the negative 3 to each of the pieces there. Now, what I'm going to do is move everything so it has a positive exponents. These are multiplied, so I can just multiply across. So I have a y squared. Now x to the negative third, I can bring that up top and make it x to the positive 3. Here's y to the negative third, so I'm going to bring that to the bottom. And then it becomes positive, so I got to get rid of the negative there. And then this is going to be a power to a power, so it's going to be x to the negative 12. So I can write it up top, make it positive 12. Now when I subtract my powers, see here again I have, and deal with the y's. 2 minus 3, so y to the negative first. And then I'm going to add my x's. 3 plus 12 is 15. I don't like this y to the negative 1, so I'm going to bring that to the denominator and make it x to the 15th over y to the first power.